geobyte.
Similarly, let us take the another important problem. Okay, look at the screen. It is asking like this. Let a wire be suspended from the ceiling, that is rigid support, and stretched by a weight W attached at its free end. Let me draw the diagram. This is the rigid support. You can also call ceiling. A wire is attached like this. Let this is the wire attached. At the downside of the wire, given that some weight is kept, this is the weight. W is equal to mg, where m is the mass of the weight. Assume L be the length of the wire and area of cross section let it be A. Then the longitudinal stress at any point of cross sectional area. You are asked to decide what is the longitudinal stress for cross sectional area is A. Okay. For that, as you know, longitudinal stress longitudinal stress equal to force on wire, external force or longitudinal force on wire divided by area of cross section. Here, external weight, whatever it is connected, is causing for longitudinal force. That means force on the wire is nothing but weight on the wire divided by area of cross section. Here, weight equal to W by A can also be written as mg by A. Therefore, option C is absolutely correct. Understood clearly? Yes. Then let us take the another important question. It is assertion and reason type of question. Given like this. Given below are the two statements. One is labeled as assertion and other is labeled as reason. Let me read the statement given for assertion. Assertion statement is the stretching of a spring is determined by the shear modulus of the material of the spring. Absolutely correct. Assertion statement is absolutely correct because you know the spring is wound like this. A wire is wound in the form of helix. That kind of spring may be called as helical spring. When you apply the force on the spring, the layers present in the spring are twisting. Because of the twisting, whatever the stresses which are developed in the spring are called shear stress. That shear stress dividing by the shear strain is the shear modulus. From that, I can conclude that the stretching of the spring, right, is decided by shear modulus. Therefore, assertion statement is absolutely correct. Now come to the reason statement. A coil spring of copper has more tensile strength than steel spring. No. Remember, the steel material is having the more tensile strength capacity than the copper spring. That means steel is stronger than copper. Therefore, coil spring of copper has more tensile strength is absolutely wrong. That means tensile strength of the copper is less than the tensile strength of the steel spring. Reason statement is correct. Reason statement is wrong. Only assertion statement is correct. Look at the options. Both A and R are true. No. A is true, but R is false. Option B is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important question asking like this. A wire of length L, area of cross section A is hanging from a fixed support. Maybe like this. Let this is the fixed support. There is a wire. That wire length is L, length is L, and area of cross section equal to A. The length of the wire is changing to L1 when mass M is suspended from its free end. It is given that at its free end, some mass is connected, some weight is connected. That mass is given as m. Because of that mass arrangement at its free end, it is given that length of the wire is increasing. That means it is extending like this. This may be the this may be the final position of the mass. So because of this extension, definitely length is changing. Given that initial length, that is original length is L, and the final length of the wire is given as L1. This is the final length L1. Final length L1. Then the expression for Young's modulus is, you are asked to decide what is the expression for Young's modulus. Okay. First let us write the change in length. You know, change in length delta L equal to final length minus initial length. Okay. This change in length delta L, right? This change in length delta L equal to, right, force multiplied by original length divided by area of cross section into Young's modulus y. Young's modulus y. From this Young's modulus y equal to force is nothing but weight only. That weight equal to W equal to product of mg. M into G into L by A into delta L. Delta L. It is equal to M G L by A into delta L is what? L1 minus L. That is the formula for deciding the Young's modulus. Look at the option C. Option C, MGL by A into L1 minus L. Option C is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important problem. Okay. Look at the screen. It is asking like this. The stress strain curves are drawn for two different materials X and Y. It is observed that the ultimate strength point and the fracture point are close to each other for material X. It is given that for for material X, ultimate strength and fracture point are close to each other, but are far apart for material Y. That means for material Y, the ultimate strength point and fracture point are away from each other. Okay. We can say that the material X and Y are likely to be respectively. Look at the different options. Ductile and brittle, brittle and ductile, brittle and plastic. Option D, plastic and ductile. Okay. For that, let us take the stress strain diagram for two different materials, namely the first one. The first one, it is for ductile material. Ductile material. And the other one, this is for brittle material. This is for brittle material. Look at the brittle material first. Look at the ultimate strength point, that is 4, and fracture point 5. These two are close to each other. From that, I can say that for brittle material, ultimate strength point and fracture point are close. Therefore, this is for the material X, that is brittle material. Now, for ductile material, look at the ultimate strength. F is representing ultimate strength, ultimate strength or ultimate tensile strength, and G is the fracture point. G is the fracture point. Look at the gap between the ultimate strength and fracture point for the ductile material, right? Both are far away. Therefore, this is for material Y. So, material Y is the ductile material and material X is the brittle material. Anyhow, for material X, the ultimate strength point and fracture point are close to each other. Therefore, the first material is brittle material and second material is ductile material. Because for the first material, it is observed that The ultimate strength point and fracture point are close to each other for material X. That is the brittle material. The other one is ductile material. Therefore, option B is absolutely correct. Understood clearly? Yes.
Geobyte.